In this module, we will be solving linear equations. A linear equation is often in the form of bx plus c equals 0, and the goal of solving a linear equation is to isolate the variable. In this case, we'll look at x as our variable. If we were to isolate the variable x, we would begin by getting the constant of c to the other side of the equation by subtracting. And then we would need to divide by the constant of b on both sides, getting x equals a negative c over b. Here we're asked to solve for t, and we have t in multiple parts of this equation, so we need to first perform some algebraic manipulations in order to get t isolated by itself. I'm going to begin by distributing 3, getting 3t minus 12. In this next part of the equation, I'm going to distribute my subtraction or negative sign, getting negative t plus 2 equals t minus 6. On the left hand of my equation, I'm going to combine like terms. 3t and a negative t is 2t. Negative 12 plus 2 is a negative 10. And now I'm going to combine like terms by subtracting t from both sides. And then adding 10 to both sides. This shows me that t equals 4. Now, I would want to double check my answer, and I can do that by plugging my answer into the original equation. Thus, I would have 3 times 4 minus 4 is 0, minus 4 minus 2 is 2, equals 4 minus 6. 3 times 0 is 0, so on the left hand I have a negative 2, and 4 minus 6 is a negative 2. Thus t equals 4 is the solution. Here I'm asked to solve for a, but I'm given an equation with fractions. And in order to make this equation easier to work with, I'm going to multiply the entire equation by the lowest common denominator of 12. This means 12 will get multiplied to every piece in this equation. 12 times 1/4 a is 3a. 12 times a negative 2/3 is negative 8. 12 times 1/3 a is 4a. And 12 times a negative 5/12 is negative 5. This equation is much nicer to work with. Now I am going to solve for a. I'm going to, again, look to combine like terms. So I'm going to subtract 3a from both sides. This leaves me with a negative 8 equals a minus 5. And now I'm going to add 5 to both sides, getting a equals a negative 3. Again, I can plug that back into my original equation to find out if that is the correct answer. And when I do that, I do find that a equals a negative 3.